Tired of slow manual calculations on site? This app generates complete structural designs instantly. Let's take a quick tour.
Here is the beam design module, which is the most detailed part of the app. You can design a T-beam, an L-beam, or a rectangular beam depending on your slab condition. Begin by entering the span and then add the basic dimensions such as the web width, the overall depth, and the slab thickness. Next, choose the concrete strength, the steel grade, and the building type so the correct live load is applied. Enter the supported slab width so the app can calculate the tributary slab load automatically. If there is a wall resting on the beam, simply enable the wall option and provide the wall thickness and height. The app will include the wall load directly in the design. After that, select the detailing inputs like the main bar size, the stirrup size, and the clear cover. Helpful hints appear throughout the process to reduce common input mistakes. When everything is ready, tap Calculate. You'll see the required bottom reinforcement, the top or hanger bars, and the stirrup spacing. You can also review the calculation log and the updated detailing drawing based on the final steel. Finally, tap Generate PDF. If a support message appears, you can watch it or move ahead. Your report will be saved automatically in the Beam Reports folder inside Downloads. Now we are inside the column design module. We begin by entering the number of stories. This tells the app how much vertical load the column is carrying through the structure. Next, enter the story height. This value helps the app determine the effective height of the column for design calculations. After that, you'll see the layout box where you can enter the span in the X direction and the span in the Y direction. These inputs help identify the column's position and the framing direction. Below that, enter the slab thickness. This is used to estimate the load transfer from slab to the column. Now move to the material section. First, select the building type, such as residential. Then enter the concrete strength, here shown as 3,000 pounds per square inch. Next, choose the steel grade, for example, grade 60. You will also see an option called frame braced in both directions. Keeping this enabled means the column is considered laterally supported in both X and Y directions. Now enter the detailing inputs. Start with the main bar number. For example, number 6 bars for primary reinforcement. Below that, enter the tie bar number, such as number 4 for confinement reinforcement. Next, provide the clear cover, the distance from the concrete face to the reinforcement. Then enter the maximum aggregate size, which helps maintain proper spacing between bars. The next two entries are optional: factored moment mux and factored moment moi. These fields are used only when biaxial bending moments need to be included. If moments are not being considered, these can be left blank. At the bottom, you'll see the option Allow Rectangular Column. Keeping this checked allows the app to design a true rectangular column with different width and depth values. Once all inputs are complete, tap Design. The app now shows the column result. Here you can see the final column size, the factored load, the steel area required, and the recommended bar layout. The screen also shows the number of bars along each direction, the tie spacing, the bar diameters, the clear cover, and a visual layout of the reinforcement. After reviewing the results, you can tap Export PDF with detailed calculations to generate a complete report for documentation or site use. Now we are inside the Slab Design module. At the top, you'll see a short explanation of the available design methods. In this example, we'll use the coefficient method, which is fast and suitable for regular slab panels under uniform loading. After selecting the method, we move to the geometry section. Here, we first enter the longer span, Ly, which in this case is 25 feet. Next, we enter the shorter span, Lx, which is 16 feet. Below that, we provide the slab thickness, entered here as 6 inches. You can also enter the clear cover, which is optional. In this video, the cover is set to 0.75 inches. Next is the material section. We begin by selecting the concrete strength, which is set to 3000 pounds per square inch. Then choose the steel grade, here selected as grade 60. After that, enter the main bar number, for example number 4 bars for slab reinforcement. We now move to the load section. First, select the building type, which controls the default live load. In this example, the slab is designed as a residential panel. The live load appears below, set to 40 pounds per square foot, and the superimposed dead load is entered as 20 pounds per square foot. Below the load inputs, you'll see the boundary condition for the coefficient method. In this case, it's a two-way slab with all edges continuous, which helps the app select appropriate design coefficients. Once all inputs are complete, tap Calculate. The result screen shows the design type, confirming it as a two-way slab designed using the coefficient method under ACI 31825. You can review the input parameters, the effective depth, the dead load, the factored load, and the design moment. A reinforcement layout diagram is also generated, showing the bar placement in both directions according to the final design. From here, you can return to the home screen or export a detailed PDF report. Now we're inside the Stair Design module. Here we are in the Stair Design input screen. First, enter the total rise, which in this example is 12 feet. Next, enter the total run. Here it's 20 feet. Below that, type the stair width set to 4 feet. Then enter the standard tread width, which is 10 inches. Select the building type, and here it's set to residential. Choose the concrete strength, shown as 3000 pounds per square inch. Then select the steel grade, which is grade 40 in this input. Once all values are entered, tap Design Stair to generate the full stair design. Here is the stair design result. At the top, you can see the basic outputs. Total rise 12 feet, total run 20 feet. At the end, tap Generate PDF to export the complete stair report. Now we're inside the brick foundation module. The first field is wall location. Here we select whether the wall is internal or external. In this example, we choose external. Next is building type. We select residential so the app can apply standard residential floor and roof loads. Below that, enter the number of stories. Here, the value filled is 2. Next, enter the story height, which is 12 feet in this input. Now move to the tributary width. This defines the load width acting on the wall. The value entered here is 8 feet. Next is the soil bearing capacity. This input controls the allowable load on the soil. The entered value is 1 ton per square foot. Below that, enter NSL below RL. This value defines how far the natural ground is below the reference level. Here, the value filled is 12 inches. Next is base below NSL, which defines how deep the PCC base will be. The value entered is 24 inches. Now enter the wall thickness. For this example, the wall thickness is 9 inches. And finally, enter the PCC thickness, which is 4 inches. Once all the inputs are filled, tap Design Footing. The app now generates the full brick foundation result. Here you can see the calculated wall load, the floor and roof surcharges, and the total load per running foot. Right below, the app shows the required bearing width based on the soil capacity and checks if the foundation is safe. Scrolling down, you'll see the auto-calculated widths for each brick step and the final PCC width. The safety check confirms whether the adopted PCC width is safe. At the bottom, the module displays the complete foundation section drawing generated from your inputs. Finally, you can tap Save PDF, Save PNG, or Save SVG to export the complete brick foundation design for documentation or site use. Now we are inside the strip footing module. The first field is concrete strength. Here, the value entered is 3,000 pounds per square inch. Below that, select the steel yield grade, and in this example, it is set to grade 60. Next, enter the number of stories the footing will support. The value filled here is 5. Then, enter the typical story height, which in this case is 10 feet. Now move to the soil input. The allowable soil bearing capacity is entered as 1 TSF. Next, enter the strip length, which represents the total footing length along the wall or columns. The value entered here is 100 feet. The next section is only for strip footings under columns. The first field is column spacing along the strip, and the value used here is 20 feet. Below that, enter the number of columns on this strip. In this example, it is 6. Finally, enter the service load per column. This defines how much load each column is carrying. Here, the value filled is 7 tons. Once all the inputs are complete, tap Design. The app now displays the strip footing result. Right beneath this, the module displays the plan view and the section view of the strip footing generated directly from your input values. At the bottom, you can export your work by tapping Generate PDF. The app will display a small prompt, and you can choose to watch an ad or simply tap Generate Anyway to create the complete footing report.
Your design toolkit is now complete. Explore every module and speed up your structural work.